Hello, my dear students. Welcome to my YouTube channel as Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the covalent bond and the octet rule. In the previous lectures, we have learned all about the ionic bonds. What are ionic bonds? The bonds that are formed by the transference of electron from the cation to the anion. But in case of covalent bond, there will be the sharing of electron between two non-metallic elements. Ionic bond is always formed between the metal and a non-metal, but covalent bond is always formed between two non-metals only. So let me write what is the covalent bond. The bond that is formed by the sharing of electrons between two non-metallic elements is called covalent bond. Is called covalent bond. Now, the elements that have valence electrons to be 4, 5, 6 and 7 will form covalent bond because the elements having the valence electrons 4, 5, 6, 7 will be the non-metals. So I am writing the elements having four, 5, 6 or 7 valence electrons will form covalent bond among themselves. Will form covalent bond among themselves. Or each other. Now, let's come to the periodic table. The group number 14 elements, group number 15 elements, group number 16 elements and the group number 17 elements will have 4, 5, 6 and 7 valence electrons. So these elements, the elements of these groups, that is 14, 15, 16, 17 will form covalent bond among themselves or with each other. Now, let's come to the octet rule. Now I'm talking about octet rule. Why do elements combine? Why do elements lose electron or why do elements gain electron in case of ionic bonds? And in case of covalent bond, why do elements share electrons? Because each element wants to achieve nearest stable noble gas configuration, that is to have 8 electrons in their valence shell. So I am writing octet rule. Octet rule. What does this mean? Every element wants to achieve nearest stable noble gas configuration. Stable noble gas configuration. That is to have 8 electrons in their outermost shell. In their outermost shell, or we can say valence shell, or we can say valence shell. Every element tends to achieve the nearest stable noble gas configuration of periodic table, that is to have 8 electrons in their outermost shell. Now, from these 8 electrons in the outermost shell, we got a word called octet. Octet means 8 electrons in their outermost shell. And how will they do it? They will do it by sharing electrons in case of covalent bond and by transferring electrons in case of ionic bonds. Now, there's one exception. In case of octet rule, we are having one exception. One exception to octet rule is hydrogen atom. Hydrogen atom. What's the atomic number of hydrogen? It's 1. So what will be its electronic configuration? Just 1 electron in the outermost shell. Now, the nearest noble gas for hydrogen atom is helium. Helium has the atomic number of 2. That is, helium has 2 electrons in its valence shell, and this shell is the very first shell. So helium has 2 electrons in its outermost shell, that is the first shell, which is complete. The first shell gets completed at the 2 electrons only. That's why helium is considered as noble gas, because it is having fully filled configuration of the outermost shell. Now in case of hydrogen, hydrogen wants to achieve only 2 electrons because it comes before helium. Hydrogen comes before helium in the periodic table. So hydrogen wants to share only one more electron to get stable noble gas core of helium gas. So what hydrogen needs? Hydrogen needs only one more electron, either by gaining electron or by sharing electron, to have stable noble gas core of helium gas. Stable noble gas core of helium gas, which has only 2 electrons in its outermost shell. In its outermost shell. So that means in case of hydrogen, we will talk about the word duplet. Duplet means to achieve 2 electrons in its outermost shell, and that goes to only hydrogen atom, because it has to achieve the stable noble gas core of helium having 2 electrons in its first shell, because the first shell has maximum of only 2 electrons. So helium is having complete 2 electrons in its outermost shell, that is first shell, so it's a noble gas, and hydrogen wants to achieve only 2 electrons in the outermost shell to achieve noble gas core of the helium. So that's why for hydrogen we will talk about duplet but not octet. Now let us discuss about the group number 18, the noble gases. Group number 18, the noble gases are helium, neon, argon, krypton, xenon, radon, and the oganesson. Now all the noble gases has the core of 8 electrons. 8 electrons in their outermost shell. In their outermost shell. So every element wants to achieve only 8 electrons. That's why we are talking about octet. But only for hydrogen, we talk about the duplet because helium has only 2 electrons in its outermost shell. In its outermost shell. Now, we have talked about the covalent bond, the octet rule, and one exception. Now, let's do some example. As an example, firstly I am taking hydrogen chloride, the HCl. Now, I am writing H over here, chlorine over here. What's the atomic number of hydrogen? It's 1. So its configuration will be only 1. What's the atomic number of chlorine? It's 17. So its configuration will be 2, 8, 7. That means when we will draw the Lewis structure of hydrogen and the chlorine, I am taking hydrogen with only 1 electron in its outermost shell, and for chlorine we are taking total of 7 electrons in its outermost shell. That is now 1, 2, 3, 4, 5, 6 and this 7. Now what's gonna happen? Hydrogen and chlorine will share 1 electron with each other. If we share 1 electron with each other, then what's next gonna happen? Firstly, talk about the hydrogen. Now this electron of chlorine has been shared with hydrogen. Now how many electrons hydrogen is having now after sharing? That's number 1 and the 2. So the duplet of hydrogen is completed. Now let's talk about chlorine now. In case of chlorine, the electron of hydrogen is shared with chlorine. Now how many electrons chlorine is now having after sharing? It comes out to be 1, 2, 3, 4, 5, 6, 7 and the 8. The 8 electrons of chlorine is also completed after sharing, so the duplet of hydrogen is completed and octet of chlorine is completed after sharing of electron. So the bond between hydrogen and chlorine will be the covalent bond because it has been formed by the sharing of electron. So this is the covalent bond. Now let's take some another example. I'm now taking the example of carbon dioxide gas, the CO2 gas. Now carbon. What's the atomic number of carbon? It's 6. The configuration will be 2, 4. Now let's talk about the oxygen. What's the atomic number of oxygen? It's 8, so it will be 2, 6. That means oxygen needs 2 more electrons to attain the octet. 2 more electrons to attain octet. Now let's talk about the carbon. In case of carbon, carbon needs 4 more electrons to attain octet. So I'm writing 4 more electrons to attain octet. So how will this happen? Let's take an example. Sorry. We are having carbon. How many valence electron the carbon is having? It's 4. So it's 1, 2, 3 and the 4. Now let's talk about the oxygen. How many valence electron oxygen is having? It's 6. 1, 2, 3, 4, 5 and the 6. We are having 2 oxygens. Let's take another oxygen over here. How many valence electron does oxygen have? It's 6. It's 1, 2, 3, 4, 5 and the 6. Now sharing of electron will take place now between the carbon and oxygen. So let's talk about the first oxygen and the carbon. This is the first shared pair of electron, the another shared pair of electrons. Now, let's count the valence electrons of oxygen after sharing electrons with carbon. Let's count. Is 1, 2, 3, 4, 5, 6, 7 and the 8. As carbon has shared its 2 electrons with oxygen and oxygen needs only 2 electrons to attain octet, so the first oxygen has attained total of 8 electrons. That's first oxygen has attained the octet and has got stable. Let me delete this thing. Now let's talk about the another oxygen. This oxygen also needs 2 more electrons, so it will also form 2 covalent bonds with the carbon. So this is the first bond, the second bond. Now let's count the valence electron of second oxygen after sharing of electron. The number 1, the 2, the 3, the 4, the 5, 6, 7 and the 8. Now second oxygen also got 8 electrons in its outermost shell. Now let's talk about the valence electrons of carbon. Now carbon itself is having 4 electrons and this carbon has got 2 electrons from both the oxygen as in shared pair. So carbon also got octet completed. Let me count electrons for you. Now I am counting valence electrons of carbon. The number 1, 2. It has been shared, so 3 and the 4. The 5 and the 6, 7 and the 8. So the carbon also got 8 electrons in its outermost shell. So that means in case of CO2, all the elements has attained the 8 electron each after sharing of electrons and has attained the stable nearest noble gas configuration. So that's all about the covalent bond. We will talk about the covalent bond in detail in our further lectures. That's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.